You are looking at a very simple code here. A struct, a value type. It has one property, value, and it's one very simple method. Multiply by it and add to the value. Did you notice anything special? You did. The in keyword. Will this code even compile? No. But why? There are two basic ways. One is which comes out by default. And 99% of the time you only need those two. If there is a value type, then a copy of that value is made and passed to that method. So if you change anything inside that method, the original value will remain unaffected. Then you can pass it by reference. When you attach a ref keyword with the parameter, it can be defined like ref int. Now the original value will change. And there is a third way that you want to pass the parameter by reference, that you don't want to deal with the complexity which comes with the ref keyword, that you have to keep track and you have to know the implementation of the method. Is it changing my value? If it does, then there can be very subtle errors which can be introduced, and they are very hard to find. So if we want to pass the reference of the value type, not the copy of the value, then what you can do is you can decorate the method with the in keyword. Here, it will pass the reference, but it will not allow you to change the value of increment like we are changing here. So if I copy this line here, the compiler is going to yell at me. No, you cannot do that. Fair enough. Let's test our hypothesis. I have written three simple tests. The value is 10. We are passing by value. You can look at the code here. Nice. It should be 10 once we get out of the method. Let's run this. It passed. Okay. Now let's look at by reference. Here, very simple method. We are passing a reference. Here I'm changing the value of the increment, the parameter here, and I expect 100. Why 100? Because we are multiplying by 10. So I'm passing 10. 10 by 10 is 100. Let's run this test as well. Now if I'm changing the value here, 10x, and let's say I want to call for whatever reason another increment, and this time I just want to do this and pass 10x off, so it's going to pass 100. So this can introduce very subtle bug which will be very hard to find. Now let's go back to the in one, the curious one. So what will happen here? First of all, this does not allow the value to change. You have already seen it, right? So it is passing by reference, but it don't allow you to change it. So you get the perf of the by ref, but you're still able to keep your code very readable, because here we are not even using the ref keyword. That is about how you pass value types. Now let's briefly look at the reference types. Okay, I have a course, and then I have assessment. Each assessment is attached to the course. So what I'm trying to do here is change the course. Okay, so this is the default way. So what is happening here is that the reference of the course is passed, but it is not the exact reference of this course variable. It is a copy of that reference which is passed to this method. That is why here I'm changing the name every single time. Here in this method, okay, name is too long, name was long. Now if I go back and run this, here I'm printing the course. What should it print? It should still print both time this value. Let's run it. You see, meaning that this change here is local, because it's a copy of the reference, not the original reference. Now let's try to use ref here. Ref change in course, ref No, not in. I want to do first this one and then the curious one. So I'm passing it by reference. Now if I change, if long, right here, the name was long, it is assigned to that. Very nice. Let's go back and run this. Now you will see that the long will be printed. Let's find out. Nice. Okay. So I'm passing a reference. Now the direct reference of this reference type. What if, same semantics, you want to pass by reference, but you don't want to deal with the complexity of keeping track of the reference, and then you have to dig in deep. Okay, what if this method is changing the value? You want to stop that. Well, ref in change here. So you don't need to specify this here. And now if I do that, the compiler yells at me that you cannot change that. And that is pretty sweet, right? Let's run it and make a guess what it should print. Well, still the same. Yep. So that is about how you can pass parameters to C# methods in different ways. And that's it. In the next video, I will try to compare the perf of passing values by reference, which can have a better perf, especially when you have large structs. Here I have given you an example of very small structure, just literally int value. What if you have a commission here, not the commission, let's say if you have a late penalty, a date time, and grace marks, a complicated struct, a value type. And then you are performing, you have a lot of students across the USA or across the world, and you're trying to calculate the score of that. And there is a calculator method, and you are performing literally millions of iterations, and it is literally on the hot path, and the perf matters to the users. Then you can try to use the ref and avoid the copying the struct, defensive copying of the struct, and that can give you a little bit boost. Well, thank you so much for watching the video. I appreciate. Kindly give me feedback if you have any. Reach me on Twitter or leave a comment on the YouTube video, and you can also subscribe if you like to. Thank you very much. Bye.